What's up, Jeremy?
Let's see. Rich, can you hear me?
I sure can.
Ah, sweet. I'm going to keep video off. I don't have enough cell service.
Gotcha.
I don't think so. I don't know if it'll pick it up. It's freaking loud, though. I got to turn it down a little bit. All right. Stop seeing the video. Super fun.
Okay, well, it's about 8 o'clock. Time for Winter School Wednesdays. And this is our last big topic-based talk on glaciology and glacier travel. I think we've got one bonus one coming up. Isn't that correct, Jeremy?
Maybe, maybe not.
Maybe, maybe not.
It
Okay.
might have gotten vetoed by the powers that be.
Well,
We'll see.
that's why they call it a bonus, right?
Yeah, it might be an encore. It might not be.
Exactly.
We'll see.
Okie doke. Yeah, we got like 15 folks in our attendee list here, which is awesome. So before we get started, before I hand it off to Jeremy to kind of give you the whole winter school introduction, I'll just say that we don't have a ton of people as attendees, so certainly feel free to type in your questions, and both I and Jeremy will be monitoring those questions, and we'll try to take pauses during the presentation and kind of answer any questions you might have. And so, yeah, if you just kind of wake up your cursors, there should be a little Q&A button down at the bottom. And you can just post questions in there, type them right in, and we'll get them answered for you as we go through. Some of this stuff gets a little technical, so I'm sure, or at least I hope, there'll be lots of questions if you have them. So yeah, Jeremy, why don't you kick us off with the winter school spiel to get us started?
Sure thing. Hey, folks. My name is Jeremy Osborne. I am the current director of Winter Mountaineering School. Rich is the future director of Winter Mountaineering School. And after tonight, I'm passing the torch off to him and letting him run with it for a few years. But kind of the short and sweet of us is we're an all volunteer group of mountaineering instructors that love spending time in the Adirondacks. Traditionally, our program is run kind of at the end of January, beginning of February in the high peaks at the lodge. And then we run a secondary program kind of mid-March, beginning to middle of March in the White Mountains for a weekend, a much smaller truncated version of the program. But we teach fundamental introduction mountaineering skills, winter camping, snow kitchens, how to winter stoves, how to deal with trip planning in a winter setting, moving around in the mountains when there's lots of snow and it's cold, is what we specialize at Winter Mountaineering School. And obviously this year, not with COVID and everything, we're doing it all online via Zoom meetings. This being, like Rich said, our grand finale right now on kind of an introduction, a little teaser, if you will, into glacier travel and glaciology, kind of what makes a glacier as opposed to just a big pile of snow. Yeah. So with that, Rich, you want to fire away?
Yep, just trying to get everything arranged here before I kick this off. Cool. I think you folks should have it now. Alrighty. So here we go. Glaciology and glacier travel. So what this workshop is, okay, this is an introduction to some basic glaciology. You will not be receiving degrees in earth science from this talk. It is also a review of some of the tools and techniques for traveling on glaciated terrain. What this workshop is not. This workshop is not a glacier travel or crevasse rescue course. Okay. It's not going to prepare you to travel safely in glaciated terrain. Okay. Those courses last 1 to 3 full days and involve extensive hand on practice by students under the supervision of a credentialed alpine guide. So, what the point of this workshop is to kind of introduce some of the concepts involved so that when you go and take your glacier travel crevasse rescue course, you can concentrate on the technical skills and the practice there, um, and having already at least been introduced to some of the concepts. And so, if this were an in-person presentation, we would all say it together. This workshop will not prepare us to travel on glaciers. That's kind of our big warning here. Okay, so glaciology. This is kind of the first big part of it. Um, if we can, if we can talk about, I'm sorry, this is just not. Don't know why that's okay. If we can, why is this not? Sorry, my computer was just hiccuping there for a second. And so, as far as what glaciers are, there's two main characteristics to it. One, there has to be dense ice and it's flowing downhill under its own weight. Okay. And these are found anywhere that the climate has allowed for many years of net snow accumulation combined with sloping topography. Right. If you have one or the other, you don't get glaciers, right? If you have years and years of snow accumulation, but no sloping technology, you get an ice field. If you have sloping topography, but your snow totally melts out every spring and summer, and you get all new snow that you only get seasonal snows, you don't get that buildup year over year. So you definitely have to have both of these things. Okay. And we can define these different zones in the glacier, right? This is just some terminology so we can start talking about them. You've got your accumulation zone. So that is where the glacier is actively building up. The ablation zone, where it's melting out, and the firn zone, right in between. Okay. And these things kind of change throughout the season, and throughout the life of the glacier. And if we can identify parts of the glacier that are safe, we can use those to travel on. And we can also use those to camp on overnight. And if we can identify very more dangerous parts of the glacier, we can either avoid them altogether or use extra caution while traveling through them, or making sure that we travel through them very efficiently and very quickly, and don't hang around in them too long. So that's kind of what we're going for here. Okay. So this number two, also, I should mention, this is that flowing downhill under its own weight. So this is a gravity driven flow. Okay. When your thickness of accumulated metamorphized ice reaches like 80 to 100 feet in thickness, that's when it'll start to flow downhill. Okay. And so that's kind of a good benchmark for like when you start to get a glacier. All righty. And so now we're just going to kind of go through a little bit more detail about these um, Man, this is just really not playing nicely for me. Okay. Here we are up in the accumulation zone, that first one that we had talked about. Okay. Just some terminology and some things that are going on here. Okay. Accumulation zone, that's where more snow is falling than melting. Okay. That's sometimes also called the wet part of the glacier. Okay. Crevasses here are often going to be covered with snow bridges. So anytime you're up here in the accumulation zone, you'll always want to be roped up because crevasses are largely going to be hidden. Okay. Some other terminology we have here is the bergschrund. It's the large crevasse forms where the moving glacier, all of this stuff down here, pulls away from a head wall. Okay. We'll talk about that in detail a little bit later, but it's just good to know that terminology. Okay. Crevasses, these things that we're trying to avoid, right? These are open cracks in the surface of a glacier. Super common glacier hazard. They occur anywhere the glacier is subjected to a sufficient tension force, right? Any kind of pulling. And they can happen in any zone, right? Not just up here in the accumulation zone. Okay. Um, Fern, also known as neve, is 1 year old transitional snow on its way to metamorphosizing into glacial ice. Okay, so that's like that 1 year old snow, not the current year's snow, but this is last year's snow that's on its way to becoming glacial ice. And then there's the fern zone, and that's the boundary between the accumulation zone and the ablation zone. Generally, it's going to be a line of elevation, right? And that elevation is going to change from year to year and throughout the season, right? Because again, this is separating accumulation where you have more snow falling than melting versus the ablation zone where you've got more snow melting than accumulating. So it's very temperature dependent and therefore very altitude dependent. And it's going to vary throughout the season. Okay. Here we go down to the bottom into the ablation zone. This is where more snow is melting than is falling, also known as the dry part of the glacier. Okay. You can often travel unroped. The glacier will be ice and bare rock. And so all crevasses are going to be visible. In other words, there won't be any snow bridges. There won't be any crevasses that are covered by layers of snow. Okay. Um, and also, it's almost impossible to self arrest on this hard ice and rock. So it's also just a little bit sketchy, and you may or may not want to rope up for different reasons that are kind of beyond the scope of this talk. Okay. Um, Two exceptions to this are if there is recent snowfall or very steep terrain, right? Then you might definitely want to rope up. And of course, when in doubt, just rope up and consider doing some kind of running protection, placing some protection kind of in between climbers, or breaking into a full fifth class belay. But again, that's going to be very, very situational and well beyond the scope of our little talk tonight. But let's get into some more vocabulary. We've got the moat here, and that is the melt gap between the glacier edge and the surrounding walls, right? So the glacier is kind of, you have to think about it, it's kind of contained within like a little valley. And where it meets the walls, it's going to kind of melt away. A lot of times, the rock wall is going to be soaking up a lot of solar radiation throughout the day, right? And so it's going to get warm, and that can cause some melt off right along those margins of the glacier there. So that's often an obstacle for climbers as we try to gain access to the glacier. We have to cross that moat, right? That can be an obstacle that can be tricky to work around. So we keep that in mind during our trip planning. Um, Another one down here, a tarn. That is a glacial lake. Again, something you don't want to have to cross. So you know that, in this particular region, if it's relatively warm out, and here in your ablation zone, you're definitely melting out, that you might have a tarn to deal with. So it's going to dictate your approach to how you gain access to this glacier and where. For example, it might be, nigh impossible to gain access to the glacier from the bottom or to cross the moat. And you might end up, going around on perhaps less desirable terrain just to kind of end run that moat until you can gain access to the glacier, right? Um, the toe of the glacier, right? That's kind of everything where it's starting to melt out the very bottom. Okay. And that's where you're going to see a lot of crevasse activity as it starts to kind of splay out, right? As it gets to the end of that valley floor. There might be some more about that as well later. Um, so there's, okay, let's talk about moraines now. So moraines are kind of where the glacier in the past has pushed a bunch of material and carried a bunch of material down and along its sides, but it has then since retreated or not, right? It still could be in contact, like close contact up here with its lateral moraine or along the side, versus the terminal moraine, where sometime in the long ago past, right, the glacier was once up to this point, but has since melted back. But it deposited all of this stuff along its terminal moraine. Okay. Um, Ice falls, right? That's going to happen where you get really, really steep terrain, and you kind of get this jumbly mess of unpredictable crevasses. And we'll get into that in the next slide as well. Um, Here we have a longitudinal crevasse, right? That's kind of part of that idea of it's spreading and that it's creating tension as it, there's a constriction here in this little bottleneck. And so after it leaves that bottleneck, the glacier kind of tends to spread out into this valley where it can be, right? And that's going to create tension left to right. And that's going to open up these longitudinal crevasses. So it really is just about trying to look at it from the perspective of trying to predict where the glacier might be in tension. And that's where you're going to see glaciers. And also, if you can determine the direction of that tension, it can tell you the direction of the crevasses. Okay. So now we'll talk about these lateral crevasses, right? That go from like left to right across the flow of the glacier. So again, they're always going to form in places of tension. And so here we show the kind of a cross section of our glacier flowing along the bedrock of the larger mountain there. And when it's creating a convex shape like this, and the ice and snow roll over it, it puts it in tension, and so you get these crevasses that open up. A lot of the a good analogy they use is like the Snickers bar analogy, right? If you took a Snickers bar and kind of bent it into this shape, you would see those things, right? It would kind of get cracked up on the top where you put it in tension, and then where it's in compression, well, it's not going to tend to open up into these crevasses. Okay. And so zones of compression, those are super safe, right? You could absolutely, set your camp there. That's good for travel, things like that. You're not going to find crevasses there, right? You're always going to, like they show here, their little flags, they've wanded out a safe zone that they've checked and probed to double check that there's no crevasses there and that they are in a zone of pure compression. But like once you've established that, that's a good place to look for it. Of course, you always want to be aware of what's above you, right? You could be standing in a perfectly safe place, but if there was an avalanche prone area above you, of course, that's not a place you want to be. Okay. But just in the context of glaciology, compression is a good spot to be. And then we see that the bedrock here continues down and then goes really, really steep over here. Okay. And so we see here that it's put in tension again, and we get these lateral crevasses. And then when it gets really steep, it starts getting super jumbled. That's the ice fall. Okay. Super difficult to navigate through there and super dangerous, especially as the day warms up and temperature fluctuations and things. As you get these seracs and these big ice blocks that can come dislodged, and it's just an absolutely terrifying place to try to navigate through. All righty. Okay, so now we'll talk about these longitudinal crevasses and marginal crevasses. And so these marginal crevasses, they're going to form due to the speed difference between the center of the glacier and the edges. Okay, that's going to happen where you've got let's see, yeah, in like a constricted path here, right? So you've got friction from the walls, so that's going to tend to slow things down, right? So the center is going to flow without that friction. It's going to be faster, but there's going to be friction from the walls of the glacier here. And so you'll get these marginal crevasses along the edge of the glacier because of that speed difference. Just in the same way that when a river flows, the center of the river tends to flow faster than the edges because of the friction from the banks. And in the same way, we can say the same thing about if there's, a turn in the overall path of the glacier, right? The outside of that turn is going to see this wall friction, and the glacier is going to try to force it quickly, right? That ice would have to move quickly in order to move with the other ice, but it can't because of the walls, and it ends up breaking up more. Okay, those are called radial crevasses on the outsides of turns where this ice has a longer path to travel. And it wants to move faster, but it can't because of the friction from the wall, and so it breaks up. Okay, and then finally down here, we can see these longitudinal crevasses, right? They go along the length of the glacier. Okay. And that happens from splay down at the bottom, right? I think I mentioned that before, where if you came through some constriction already, and then after it kind of spreads out onto a valley floor, it tends to spread. And then that splay, those lateral forces are creating tension inside the glacier, and that's opening up these crevasses along the length of the glacier itself. Okay. So here's a cross section of what a crevassed glacier looks like and kind of all the different layers that we're talking about here. And so start at the bottom, the bedrock, right? It's a lithified, a compacted rock layer underlying any loose material that's on the surface, right? So that's like all the super, super well consolidated rock that's underlying all of our mountain features. Okay. Then you've got this plastic layer. The plastic layer of the glacier, the pressure down here is sufficiently high, right? Because you've got the weight of all of this stuff up here pushing down on it. And so the pressure, just like water pressure increases with depth, so does pressure within the glacier. And this plastic layer down here, the pressure is sufficiently high to let ice flow plastically, right? Just kind of moosh around any bedrock without cracking, right? If there's any features down here in the bedrock, like some protrusion or something, and it's sufficiently attached to the bedrock where it's not just going to like pull away from it, that glacier is just going to flow right around it. As if it were like lava, molten, plasticky stuff, goo. So no crevasse. The takeaway is that no crevasses can form in the plastic layer, right? The pressure is so high, and it tends to flow much nicer that crevasses never open up. That's the big takeaway about the plastic layer. Then we come up into the crevasse layer of the glacier. Okay, you're talking about a thickness here of anything from 100 to 200 feet thick. Okay, that's when the pressure isn't quite high enough to prevent the cracking. Okay, so, but we do know that pressure does increase with depth. So as you get deeper, right, that pressure is going to increase and the cracks are going to be fewer and narrower, right? Like, for example, you'll get lots of cracks up in the surface, up near the top, but only a few of them will be large enough and deep enough to get all the way to the bottom of that crevasse layer. And so, and obviously you can see they're getting narrower and narrower. Okay. And then finally, on top of the crevasse layer, you've got the snow layer, right? So that's 1 or 2 years of snow, right? Before it starts to accumulate into metamorphize into glacier ice. And that's where we see snow bridges. That is this one right here. This is your snow bridge, right? You got that layer of snow covering an otherwise open crevasse. And here you've got the rope team here, and that first climber is kind of probing things out, and his ice axe went all the way down. Um, didn't hit ice, went right under went right through the snow into the crevasse itself. And so, snow bridges, they're going to vary in thickness and strength by the season, by the day, and even by the hour. And so, a snow bridge that may have been safe to cross during the morning when things are cool and maybe a super low angle sun, that could be very, very unsafe and start to melt out in the afternoon when things start to warm up. So, snow bridges can be very, very safe and let us travel easily, or they can be a little bit sketchy. It's going to depend. And then, when you actually start, getting experience on a glacier, that's when you'll start to learn from, people who know about what is a safe snow bridge versus an unsafe snow bridge. Okay. Now we'll come back to the Bergschrund. This is, like we said before, it's where the moving ice separates from the head wall. And so the head wall, it's an angle that's so steep, right? This angle here relative to the ground, that angle is so steep that snow constantly sloughs off of it, right? It never gets to accumulate because any snow that develops on here is just going to fall right off onto the glacier itself. But it does get plastered with ice from, wet storms and things like that, and freezing temperatures and things. So there may very well be ice on there, but that's going to be stable. It's going to be stuck to the rock. It's holding the rock together. The rock is holding it to the mountain. But it never gets to accumulate any snow depth. and therefore it can't form a glacier, right? That was one of our conditions, that you needed depth of snow to form a glacier. Head wall doesn't get it. So what you do have is down here on this lower angle terrain, right? That's where you're going to get your glaciers. You've got that angle. It's large enough to produce a downhill slope, but it's not so large that it stops snow from accumulating. That's where we're getting our accumulation of ice that hundreds of feet thick, and it starts to move under its own weight. And this, the Bergschrund, is where it kind of pulls away. And so you've got the snow that's accumulating on the glacier itself. You've got the snow that's being sloughed off of the head wall, sometimes backfilling the Bergschrund. But in any case, it's all moving downhill and pulling away from the mountain. And this can create an often very wide and chaotic feature that can be difficult to cross. Sometimes they are relatively shallow because, like I said, depending on the time of year and the conditions, there might have been some snow on here that it all sloughed off and bang, filled in that Bergschrund. Okay. Doesn't mean it's necessarily easy to cross, but it might not be quite as deep as you expected. Okay. So just kind of as a summary to like wrap up a lot of our vocabulary and the things we're talking about, we've got the three zones in a glacier, right? We've got our accumulation zone up at the top where more snow is falling than melting. We've got our ablation zone at the bottom where more snow and ice are melting than are accumulating through snowfall. And then in the middle, you've got your fern line or your fern zone, right? That's that transitional zone. And each one kind of presents its own challenges. No snow bridges down here. Cool. I can see all the glaciers. Less cool. Not a lot of snow to do a self arrest. Up here in the accumulation zone, hey, lots of snow bridges. That could let me cross a glacier without having to fall into a crevasse. Oh, but wait, they might be really thin and I might fall in anyhow. So it's kind of pluses and minuses throughout. Okay. And glaciers and the features you see are going to vary greatly from range to range, right? It might be a lot different in the Cascades versus the Himalaya versus the Andes, and also throughout the year. So that's part of your trip planning. Learn about the particulars of the glaciers where you're going. Okay. And the big hazard that everyone wants to avoid, these crevasses, right? They form near the surface in zones of tension. So, kind of, if you always keep in your mind that the glacier is really just like a big candy bar that'll crack if you bend it too much, and just kind of envision taking your candy bar and put it into the shape of the path of the glacier, that'll help you envision what might be in tension versus what might be in compression. Compression, no crevasses, safe to travel, safe to camp. Tension, lots of crevasses, better look out. Okay. Um, crevasses can be navigated over or around depending on your conditions. And you also have to be aware of features such as, an ice fall, right? Super tricky terrain. Might want to circumnavigate that. Any of the seracs that might be in there, right? These big blocks of ice that we get on glaciers sometimes. Bergschrund can also be a very considerable obstacle, right? So those are kind of the big ones those are your really big concerns. So crevasses, it's a more pedestrian concern. There's always going to be there no matter where you are on the glacier, except in the compression zones. But that's kind of, if you're on the glacier and you're moving on the glacier, climbing the mountain, you're always going to be dealing with crevasses. Things like ice falls, seracs, bergschrund, those are less common as far as how many you have on the glacier, but they're also very much more dangerous. So it's kind of a different type of risk to manage in that way. Okay, so now we've kind of done the background glaciology. Now we're talking about actually walking on the glaciers. Right, and here's a rope team of four climbers crossing a very nice snow bridge down in the Andes. So first, some tools and terminology, some stuff that we use for navigating around on glaciers. All right, we've got our non-locking carabiner, right? Just a regular old wire gate. Right, that gate will open as soon as you push on it or throw a rope through it. Number two, a locking carabiner, right? This one happens to have a screw lock, like a barrel that'll thread up and stop that gate from opening, kind of an extra safety feature on it. Lots of other locking mechanisms out there, but this was kind of the original and still has a lot of good use. Number three here, that's a Petzl T-block. Um, it's a good way to grab onto the climbing rope and attach another rope so that you can pull on it, right? That's one of our big things in crevasse rescue is to be able to pull on the climber's rope to try to extract the climber, right? And of course, you can't provide enough traction, just with your hand to pull somebody out. And so we have to use technology and devices in order to get enough traction on the rope and to be able to put enough force on that rope in order to pull a climber out. Okay. T-Block's a pretty good device. It's very lightweight and small, weighs about 39 grams, but it'll cost you about 35 bucks. And so we'll kind of get into some of the other techniques and methods you can use and some of the advantages and disadvantages, different things like that. Number four is a Petzl micro traction. It'll cost you about 85 grams in weight. It's about 120 bucks. This is a high efficiency pulley with an integrated progress capture device, right? So you can see here, we've got kind of the roller in here, right? That's where your rope's going to go as a pulley. You got a spot here where you can attach a carabiner to it to attach it to an anchor. And then up here, you've got this progress capture, right? Those are like teeth that are going to hit the rope and stop it from going back so that when you're extracting a climber, right, and you pull on the climber, that high efficiency pulley makes it so that it's relatively easy to pull up, even if you have a 180-degree bend here. And then that progress capture is going to make it so that it doesn't slip back down. Okay. Again, there are ways to do this without the fancy tools. And we'll get to that in a second. Part of any glacier travel kit, number five, is an avalanche probe, right? This is deployable, right? So it kind of works a bit like a tent pole, right? Where it's got the cable running through it and you can pull on the cable and lock it in place and it makes it straight. They're usually, I don't know, about 5 or 6 feet long altogether. A must have when in avalanche terrain, right? If you're looking for a buried victim, but also super, super handy if you're traveling on a glacier. First climber in the party has the Avi probe looking for crevasses, right? It's quite a bit more comfortable to use than bent over probing with your ice axe. So that should be part of any glacier travel kit. Number six, this is a snow picket. They're about 2 feet long, about 60 centimeters. These are designed to be driven into snow or the less dense ice and can be used as an anchor. Right, got lots of holes here where we can clip carabiners, we can pound them in and clip to the top, we can clip to the middle and bury it. in snow to create an anchor. Lots of different stuff we can do to this. This one's just kind of made out of a piece of angle aluminum. I don't know, maybe inch and a half on each side. Like I said, about 2 feet long. Number 7, not the climbing rope. This is a cordelette, usually about 20 feet long altogether, 7 meters approximately. Rope diameter 6 to 7 millimeters is pretty standard. And this is a static cord, meaning that it doesn't have a lot of stretch or bounce or shock absorption like a dynamic climbing rope would. Okay. And that's going to be part of our toolkit for kind of rigging up all of our rescue stuff, right? To perform an extraction if someone does fall into a crevasse. Number 8, a plaquette style belay rappel device. This one here looks like a Black Diamond ATC guide. And so this is really any, of the very standard plaquette type belay devices. They work really, really good, as either a progress capture. It's something you're going to have with you anyhow on a technical climb as a belay and rappel device. Lots of uses in setting up hauls or in doing an extraction from a crevasse or a fallen climber. Number 9, of course, ice screws. Right, that's whether you're doing waterfall ice climbing in the Adirondacks, or if you're doing any alpine climbing, you're probably going to have at least a few ice screws. Really, really useful for performing a rescue in the ablation zone. Remember that dry part of the glacier where you're not going to have snow there to drive in a picket, right? Snow doesn't accumulate there. That's melting off. That's down low. You've only got all that solid glacier ice. And so that's where these folks come in handy right here. Okay. Number 10, an assortment of slings and runners, right? These are kind of these woven corded materials that we use, and usually just complete sewn loops, right? Kind of half a picture of them here, coming in different standard lengths. On any technical climb, you're going to have a mess of them. These shown here are the Dyneema fabric, which definitely has advantages in the alpine. They are much lighter weight, and they also do not absorb water the same way that nylon does. So in the alpine, generally preferring Dyneema for that sort of work. Okay. This is kind of what I was getting into before about, whether you buy the fancy Petzl micro traction or make do without. And so, there's a big debate over specialized equipment versus improvised equipment, right? If it's something like a belay device that you're going to have with you anyhow, perfect. Does double duty. But some things are less so, right? Like in this top illustration, we can see we've got one of these high efficiency pulleys. It's great to have, but it's going to cost you money. And it's going to cost you weight. So you got to ask yourself, well, yeah, there's considerably more friction that's going to be in the system if I'm trying to pull on these ropes and execute a rescue. Yeah, I'm definitely going to have more friction here bending it around just the inside of that carabiner there. But is it worth it to carry the pulley around? Right? That's a judgment you'll make based on experience. Okay. And here we have, this is an ascender, right? You'll see that a lot on like the Mount Everest movies where you got a bunch of tourists kind of jugging up the line, right? A fixed line, and they're just kind of, keeping their progress on it using one of these, right? This could be great to grab onto a rope with, right? Ascenders aren't cheap. You might not be having one on your climb anyhow, right? So, hey, maybe I can come down here and just tie a Prusik instead. Yeah, there's definitely disadvantages to the Prusik, but I have this cord with me anyhow. Okay, so these are kind of some things to consider based on the climb you're going on, based on a lot of what your party is comfortable with and knowledgeable with, right? Because the equipment that you as a party as a whole are familiar and comfortable with, um, way better than bringing all kinds of fancy gadgets that maybe not everybody's familiar with. In a rescue scenario, you want everyone familiar with the equipment you have. Okay. Next up, if you're going to be doing any kind of technical climbing, or especially any kind of glacier travel, crevasse rescue stuff, there's a handful of knots and hitches that you'll definitely want to learn. Um, Obviously, a lot of YouTube videos on how to tie these. So we're definitely not going into that. This is more of an awareness of things to seek out on your own, right? Overhand on a bite, that's super important. Tying it on the rope, things like that into the middle of the rope. Um, Super, super common. Figure eight on a bite, again, very common, has, some technical similarities and notable differences to the overhand as far as application. But again, super important knot. That's our climbers tie in knot, right? A lot of times. We do the follow through, of course, but um, then we've got some hitches down here. We've got the clem heist. That's a good one to know. Grabs onto the rope. Not quite as strong as the Prusik hitch does, but the Klemheis does tend to work a lot better with webbing than it does. The Klemheist tends to work very, very well with webbing, whereas the Prusik does not. So if you're going to use a piece of webbing to try to gain traction on a rope and pull on it, you're going to want to tie your Klemheist instead. Okay. Clove hitch, super duper important, super fast to tie. Um, Great for, arriving at an anchor and looking for security. Bang, clove into that anchor and you are secure. Absolutely fundamentals into the clove hitch. And finally, the Munter Mule overhand combination. Um, this one can be a presentation in itself. So many uses. Takes a little bit of practice to get and to tie correctly and to use correctly. But the combination of the Munter hitch, the mule knot, and the overhand backup is super, super powerful, and one you will learn in any glacier travel and crevasse rescue course. Okay. As far as gearing up, this is the stuff you're going to have and how you're going to carry it, right? Ice axe, absolutely. you know, Arresting either your fall or the fall of the entire team. Remember, you're all roped up. If one person falls, you are instantly going to self arrest, even if you're not the person who fell. Okay. Um, Climbing hardware, including your rescue tools, right? You can see we've got an ice screw down here. He's got his cordage there, his cordelet, belay device, all that stuff right on the harness, nice and accessible. The harness itself is a lightweight alpine harness. Right? This isn't the harness you're going to wear to the crag and whip on all day and sit in and all that stuff. This is, I'm not expecting to fall. I want super lightweight, um, enough to do the job, but not bulky, and often has a drop seat. Drop seat meaning you can kind of drop the leg loops and separate them so that when it's potty time, you don't necessarily have to take your harness off and expose yourself to a dangerous fall. So these are features of an alpine harness. Of course, you're going to tie into the climbing rope, right? We'll get into that a little bit later. And extra rope. We'll see in the rope team that there will always be extra rope in the system. This is so that when and if one climber falls in, there's always enough spare rope lying around to effect a good rescue. And finally, a helmet, right? We're in the Alpine. Things get knocked loose, people drop gear, wear your helmet. Okay. Now we're getting into, you know, actually setting up your rope team. Okay. So in general, you're going to be talking about teams of at least three climbers is good. Affecting a crevasse rescue where you have one victim down in the crevasse and only one climber on the top side is extraordinarily difficult, and in my opinion is a travel method that should only be taken upon by people who really know what they're doing in terrain that they are really familiar with, and even then super risky. So let's talk about the most common scenario of a three climber rope team. Okay. So in order to set up your rope team, you're going to double flake the rope, meaning that, you're going to kind of grab both ends and kind of through your hands, flake it out into a pile, and this will let you find the center. Modern climbing ropes are either from the factory or often put on by the end user, a nice middle mark, and that can help you, but you shouldn't trust it absolutely. The middle mark may not be the middle mark if someone trimmed their rope for some reason. Um, so yeah, double flake your rope. You should be flaking your rope anyhow to look for any defects in the rope. So that's a good time to take care of that as well. You're going to find that center, tie that knot we saw, that overhand on a bite. Now you've got that center marked. Now you can double flake out 10 meters of rope from the center, tie two more overhands on bites. Now you've got three loops that the climbers can clip into. Okay. And there's some difference about whether or not you're going to use mountaineer's coils to store your rope or kiwi coils. It's a little bit beyond what we're doing, but if you're going to be using the mountaineer's coils, right, your end climbers are going to clip into the overhands. If you're using kiwi coils, that's a different tie-in method. And the two overhand knots that you tied, those are just going to serve as markers for those climbers to tie their kiwi coils. Okay. As far as the separation here, it's going to vary by terrain, but 10 to 12 meters is a pretty good starting point, right? And that's why we're kind of double flaking out that 10 meters, right? To get that separation. That's when we're setting it. Okay. Before we were roped up on the glacier, we get together in a team and say, yeah, let's do 10 meters, let's do 12 meters, right? Then you start your setup. 10 to 12 meters is long enough so that no two climbers are generally going to be on a snow bridge at the same time, right? You're not going to see snow bridges that are 10 meters wide, right? And it's not so long as to be unmanageable or to potentially have two climbers each on a different snow bridge, right? So it's kind of a sweet spot in that way. As far as the rope itself, a 60-meter rope works really, really well for a three climber team. You'll have 10 meters between each climber, and about 20 meters coiled up on each end. A little less, right, due to knots and things and all of that stuff. And that's great because you always want to have at least several more meters rope coiled than the separation distance in order to execute a rescue. Okay. And obviously this is a team of three that we've drawn here. Teams of 2 and 4 aren't uncommon. A team of 5 is probably the practical maximum. I don't think you're ever going to see any serious alpine climbing party climbing in a team of more than 4 on a regular basis. Even though we're not getting into the details about the Mountaineers coils versus the Kiwi coils, it's good to know that Kiwi coils are good for separating, for adjusting the separation, right? It's going to be easier to adjust this 10 meters if you need to. Also good for switching between glacier travel and pitched out fifth class climbing or short roping. Whereas the Mountaineer's coil, it's a little bit simpler, and it's good for an all day at one length. It's easier to swap positions on the rope. And if you don't want to wear the rope as a coil, if you're using Mountaineer's coils, you can clip into the rope and then just shove the rest of that rope in your pack. So, kind of some practical differences in there. Okay. Tying into the climbing rope. Okay. So, what you're going to do is you've got your harness belay loop, right? That's attached to you. Uh, Pretty standard method, one locking carabiner, one non-locking carabiner, opposite and opposed. So what this does is it provides some amount of redundancy using two carabiners, um, and it's enough safety against gate opening with just the one locking carabiner, right? Because we're not bringing infinite amounts of equipment with us. We want to save some of our locking carabiners to have on our harness to effect a rescue, to build anchors, and things like that. And so this combination with this particular orientation is going to give us enough safety without being burdensome. Okay. And the reason why we're putting them in this configuration with opposite and opposed, meaning that the gates are on opposite sides of each other and have opposed motion. That is so that any lateral forces or knocks and bumps are only coming into contact with one gate at a time, and you're not opening both of them. Here's the overhand on a bite that you formed when you were flaking out your rope, and you're clipping in. And you should leave enough room here in this knot for one additional locking carabiner, but not much more. You don't want too much slack in there. Okay. Some notes about this stuff. The belay loop. Some alpine harnesses don't have a belay loop, especially older ones, but most modern harnesses do. If you've got an older harness that you're working with, you'll often put the carabiners right onto the structure of the harness itself, and it's not a separate loop for it. And we are, yeah, we talked about the loop size here, right? You only want for that one more, just because it gets sloppy if that loop is too long. And then as far as knot choice, we use an overhand on a bite, mainly because there is the potential of loading both of these strands, right? We could end up putting a lot of tension on these two strands if there is a fall. And if you dig into some of the knot technology, right? People might say, "Oh, I'm going to use the figure eight on a bite there because that's a standard climber's tie-in knot and this and that." But if we're loading both of these strands, a figure eight can actually capsize and roll and take up more and more material until your hole here disappears. And that's not a situation you want because you need to be able to add things. You need to be able to access that loop. You need to be able to potentially unclip from that rope in certain situations. And so that's why we're using the overhand on a bite, just a little bit of not geek stuff there. Okay. Communication while your rope team is on the glacier. Okay. Zero, right? When you call out, when one climber calls out zero, that means stop. It's initiated by any climber who needs to stop for any reason, right? Whether it's a potty break, whether it's food, whether it's I have to stop and check my compass or my GPS, whatever it is, zero. It's going to get repeated up and down the rope line. Oh, okay, yes. Frank in the chat has asked, what about the alpine butterfly? Great question, Frank. So as far as a tie-in knot, I'm just going to bump back a slide because I think we do have, well, we are running a little shy on time, but there's not too many slides left. Um, Alpine butterfly is great for loading all of the strands. The disadvantage of it is that it's simply just more fiddly to tie. So I don't use it, but a lot of folks do. And yeah, so that's kind of the one downside is that, I can tie, I'm sure with practice, of course, people can tie alpine butterflies, as fast as anything. But just the overhand on a bite is super easy and it is sufficiently strong for what we want to do. Okay. So back to our communication. 0 is stop, right? Um, and so we're going to repeat that up and down the rope line, right? So one climber says 0, and then the climber way in the back may not have heard it. So middle climber yells out 0. Everybody knows. Okay. Um, and also, if people are trying to get moving, you could also yell 0, like, hey, I'm not ready yet. And we don't say stop because that can sound a lot like rock. And that's not a good word. That's a danger word in climbing. Right? That's look out for falling rocks. Clear, that's I'm ready to move. Right. So if the rope team is stopped and it's like, okay, everyone's had a drink. Leader says, hey, is everyone clear? Okay, clear, 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 up and down the line, ready to move. Falling, right? That one's obvious. Watch me, that's a good one. That's I might fall. That's, hey, I'm up in front of this crevasse and, I'm pretty sure I can just step or jump across, but, watch me. I might fall. Be prepared. I may fall. Slack or tension, right? That's a request for rope movement. Faster and slower, that's pretty obvious. A request for a travel speed change. And here's a big one: all all verbal signals are going to require a response of some kind. Right? We have to make sure that we're being heard and acknowledge it. Right? If someone says tension, I say, oh, tension on. Right? Everything gets a response. Right? On belay, belay on. Right? The belay sandwich. Always about the communication. Okay. There's also kind of natural rope communication. If you find that you're on the rope team and there's too much slack in front of you, just slow down a little. That slack's going to disappear. Are you feeling a tug from behind? Well, just slow down a little. And the climber behind you, won't be pulling on you so bad. So, it's a little bit awkward at first, but you eventually get the rhythm and you can move efficiently. Okay. Also come along with hand signals. Right? These are some pretty standard alpine hand signals like, hey, okay, everything's cool. Clear, ice axe straight up, ready to go. 0, nope, I need to stop. Go over here, waving your arms around, danger. Right? Like if we're stopped and someone's like, what's going on? You can be like, hey, there's a big crevasse here. So there's some hand signals in case it's super, super windy out, right? A lot of times your voice won't carry. All right. Taking breaks. Definitely want to stay roped up. Um, you might be confident that there's no crevasses around, but really there is no reason to unclip from that rope and go wandering around. Take your breaks. Take them spread out, right? If these 3 climbers were all together and roped up, well, they could all be on a melting snow bridge and fall into a crevasse. So not only stay roped up, stay spread out. And so, if you do have to do things like switching positions on the rope and things like that, you're definitely going to want to probe out an area and make sure there's no crevasses around before you go doing any kind of fancy dancing like that. Okay. Um, Safety while we're climbing. We have to remember um, movement. Your movement as a climber is always your primary safety system. right? Your skills in navigating this terrain on foot, that's your primary safety. The technical rogue system is a backup. Okay. We're going to use that only in the case of a fall. It's good to think of the mountain environment in terms of fast snow versus slow snow. Yes, it's a terrible tongue twister. Fast snow is if you fall, you're going to slide and accelerate, right? That's the kind of snow you definitely want to be roped up for. Slow snow is like if you're moving and you're getting the sense that, like, yeah, if I bit it and fell down here, I would just fall in the snow and the snow is going to stop me. That's probably okay. It's probably okay to travel unroped in those conditions. Many of the things we encounter in the Adirondacks qualify as slow snow, right? Any trails or slides that are in good condition, that's your slow snow. Um, Cross crevasses at right angles, right? That's the shortest distance across. It prevents pendulum falls, right? If you fell into a crevasse and went along it, that would be a terrible way to spend the afternoon. Um, and so always want to cross at a right angle. That can, of course, be difficult with those longitudinal crevasses that go up and down the glacier, right? We're trying to go up or down the glacier. We're either approaching the climb or retreating from the climb. So that can be very, very difficult to navigate, but you have to do your best. Um, Identifying hazards and steering clear, right? Um, Not only being able to spot a hazard like a giant serac or an ice fall or a crevasse, right? Being able to identify one when you see one is good. Knowing where they are likely to occur based on topography, that's even better. And remember, all of these things can vary widely from mountain range to mountain range and throughout the year. You've got to research, your objective. Um, and exploit safe ground to move quickly. Speed is safety. You are minimizing the time that the party is exposed to objective mountain hazards. Um, you know, I always, find a hard time combating with this where it's like, well, I want to spend time in the mountains, but yeah, here I am trying to move quickly and not minimize my time there. But you have to realize there's times when it's safe to go slow, and there's times when safety depends on moving fast. Um, get an early start, right? No one ever regretted an early start. Get that alpine start dialed in. Get your 3 a.m., 4 a.m., midnight start, and try to be off the mountain before the afternoon sun hits and starts melting out all your snow bridges. Okay. Probing, right? We've got our nice long avalanche probe here. And so you're kind of probing for that thickness, right? As this climber was approaching and going across this glacier, probe stops at the glacial ice, goes a really long way before he punches through the air. Felt pretty good about it. Continue. Wow. Okay. That got thin. Time to do something about it. Now this is something to negotiate. How thin is too thin? That's going to depend entirely on the strength of the snow itself and the aspect ratio of the snow bridge, meaning its kind of thickness to span ratio, right? And that's going to change. That thickness is going to vary with these snow bridges. So it's a little bit of a dark art to it. And that, is something that, your guides and your mountain educators can teach you in the field. Some marking techniques, right? If you do come across a crevasse and you've probed it out and you found exactly where these borders are, draw a couple of lines on it with your ice axe and put X's on it. That means crevasse. right? An X in climbing always means danger, right? So it's not where the treasure is. Don't do that. Um, so you X that out, and people know to, oh, I can just hop right across this based on the lines that I put there, right? Same thing in rock climbing. You see the chalk X on a rock? That's a dangerous loose rock. So X is bad. X is danger. That's your do not step. Okay. And this is for snow bridges that you can cross and that you're not going to walk around, right? This climber, she can just hop right over that, but you wouldn't want to step right on there. Okay. If you come to an open crevasse, you've got a couple of options here. You can either jump or step across, right? But you're going to be backed up by some kind of a belay from your partners, right? And you can see this climber, he made the leap of faith across here, and he's already in his self-arrest mode, right? If he kind of shorts it, his the pick of his ice axe is ready to dig into that glacial ice and hopefully stop him from falling into their crevasse. Other way, end run. Just keep you come and hit a crevasse and it's super wide and you can see it. Well, start going around it, but there might be a snow bridge at the end. So probe it. Well, that climber probed here, still felt air under there, still felt air, didn't feel air up here. Well, end run that crevasse. That can add a lot of miles to your day, but sometimes that's the only way around. Okay. Last slide. I apologize. We ran about 10 minutes over here. Here's some good references and some further study. A couple of good books up here at the top. Wilderness Mountaineering by Phil Powers. That's an awesome one through Knowles. Glacier Travel and Crevasse Rescue by the Mountaineers. That's another classic. Of course, Freedom of the Hills, right? Mountaineers Bible. Got to get your hands on that one. And then Glacier Mountaineering, an illustrated guide to glacier travel and crevasse rescue. That was a super duper book. And of course, these organizations can help you a lot. And this is a lot of where I got my own material for this presentation. Obviously, us here at Winter School, we can always point you in the right direction of things. American Alpine Club, awesome all volunteer club for climbing of all kinds. The American Mountain Guides Association, right? Count on these folks to educate you with the most up to date and certified techniques in the mountains. And then SIET, the School for International Expedition Training, where I did some training myself and learned a lot of these techniques in the field. And I'm now trying to pass them on to you. And so I don't see any open questions, and we are at time. And so I will wish you all good evening. Thank you all for coming out again. My name is Richard Murray, the incoming director of Winter Mountaineering School. It seems that Jeremy has dropped off the call. Jeremy, that lucky duck, is ice climbing in the Sierras this weekend. And I am here delivering this to you. So yeah, we are all volunteer. We, of course, are doing virtual Winter Mountaineering School this year, but we very, very, very much would like you to come to our in-person program, which I am really hoping we can do this year, kind of counting on it myself for my own sanity. Excellent. Getting some good comments and stuff. So super duper. You folks all have a great evening. Stay safe. Keep getting outside. The pandemic will end, and we will see you in the mountains.